The next template is networks always play by the rules. The name of the anti-pattern is networks always play by the rules. It's also known as trust all servers, trust all clients. Do you believe in magic? Refactored solution names. System hardening state-of-the-art wireless security protocols. Unbalanced primal forces. Management of confidentiality and integrity. Anecdotal evidence. In wireless, the access point with the strongest signal is the one that user devices will trust, even if it is malicious. The anti-pattern solution. The internet was not designed with the security in mind. Neither were many wireless technologies. For example, both Wi-Fi enabled laptops and global systems for mobile communications, GSM cell phones, accept any base station that knows the respective protocols. There is a free security tool called as Karma that can turn any Wi-Fi enabled laptop into an imposter wireless access point, described as Internet in a box. Karma fools the laptops into sharing their cookies for major websites and other purposes. Yersinia is a security research tool that generates the network layer 2 attacks. The data link layer protocols on this layer generally do not authenticate other systems, meaning whatever frames they are sent are accepted as valid and acted upon. This is the general vulnerability responsible for ARP cache poisoning, corrupting the machine and internet addresses. Yersinia can perform host spoofing and monkey in the middle attacks on 6 additional protocols including Dynamic Host Configuration Protocol DHCP, which is responsible for assigning Internet Protocol addresses to machines. Many of the security issues on the Internet are due to software assuming that all others are playing by the rules. For example, assuming that other programs follow all of the Internet requests for command standard specification and always exchange reasonable parameters. Cyber exploit code and malware exploit these design assumptions by deliberately breaking the rules and catching the technology off guard, causing the targeted software to perform operations it was not designed to do and on behalf of the attacker. In the next field, we have causes, symptoms, and consequences. The causes, symptoms, and consequences of this anti-pattern include lack of server authentication. It can be because of HTTP, Wi-Fi, GSM, DNS, SMTP. Lack of client authentication, HTTP or HTTPS. Not monitoring networks for malperformed protocols and packets. In the next field, we have refactored solution and examples. There are many inherent weaknesses in the internet technologies that you cannot mitigate. What you can do is use cybersecurity best practices to make your system hard targets. For example, harden the system configurations according to the best practice guidelines. Use the most advanced updated solutions for antivirus, anti-spyware, IDS, IPS, and host-based security system HBSS. Configure the systems such as Wi-Fi enabled laptops to require host authentication. Engineer security into the system from the beginning of the development cycle. The last field, related solutions. Some authorities have argued for a fundamental rethinking of the internet with much stronger support for delegation of trust and attribution of user actions. The next anti-pattern template. Hard on the outside, gooey in the middle. Anti-pattern name, hard on the outside, gooey in the middle, also known as Tootsie Pop, defense in depth, perimeter security, protect everything from all threats, refactored solution names, HBSS, network enclaves, unbalanced primal forces, management of confidentiality, anecdotal evidence. Each user's browser is sending thousands of spyware beacons every day. Advanced persistent threat. Our networks are totally secure. We have a firewall. The anti-pattern solution. Traditional network architectures include three major domains: the Internet Boundary or DMZ, the Data Center Storage Area Network SAN, and the rest of the network intranet. Between the DMZ and the intranet, there are network security devices, including a firewall and possibly an IDS or IPS. Network security is concentrated at the firewall, and the firewalls are assumed to protect the entire network. In theory, firewalls protect the network by hiding the internal IP addresses through network address translation and blocking the incoming packet traffic on denied port numbers. In practice, most packet traffic is concentrated on very few outgoing ports, primarily 53, 80, and 443. These correspond to the domain name system, HTTP, and HTTPS protocols, which are the core protocols of the World Wide Web. These outgoing ports are open on virtually all firewalls. Malware and spyware writers are well aware of this fact and craft their code to take the advantage of these ubiquitously open ports. Botnet malware and browser-based spyware send beaconing packets from infected machines inside the firewalls to the port 80 on external control servers. To the firewalls, these packets appear to be ordinary web traffic. In drive-by malware, attackers take the advantage of the fact that most internet browsers are configured to execute scripted code by default. If your browser encounters a malware-infected site, attacker code is executed on your system. Drive-by malware sites are widespread on the internet. Inside the firewall, there are a few internal protections and intranets. However, the greatest threat of all, the insider threat, is inside the firewall. Insider threats are most dangerous because they have legitimate network credentials and they know about the most valuable information too. External threats penetrate the networks and get inside the firewall, often through stealthy means. In a common APT scenario, specific employees are studied using their online information such as Facebook pages, LinkedIn profiles, and other public data. In phishing attacks, targeted emails are crafted with malware attachments, preying on gullibility and curiosity of people. The malware is opened and the system infected with, for example, a keylogger. The keylogger sends keystroke data back to the attacker on report on port 80, quickly gaining the user's login credentials and eventually a system administrator credentials when they log in to perform maintenance. With administrative credentials, the malware can be propagated to many other machines inside the firewall. In effect, the entire intranet is owned by the attacker. In the next field, we have causes, symptoms, and consequences. The causes, symptoms, and consequences of this pattern include no protected network enclaves inside the firewall on the intranet, no HBSS, no configuration monitoring. Other cyber anti-patterns such as never read the logs. In the next field, we have known exceptions. For small networks of perhaps fewer than 50 users, a traditional network architecture might be workable. However, additional measures such as system hardening and HBSS should be implemented. In the next field, we have refactored solution and examples. For larger networks with extensive information assets, intranet security should be very carefully designed. What are the most critical information assets in the enterprise? These deserve additional protection, such as a separate firewalled network enclave with IDS, IPS network monitoring. Security should be focused on the assets most deserving of additional safeguards. State-of-the-art security solutions include continuous configuration monitoring. There are tools such as Tripwire that monitor the changes to key system files, files such as kernel and dynamic link libraries. Other tools encapsulate both the file system changes and application program interface calls, that is, API calls, preventing malicious actions such as the McAfee HBSS. Some tools perform periodic security vulnerability and configuration testing, such as Retina from EI, Nessus from Tenable, and Nexpose from Rapid7. The next anti-pattern template is Webify Everything. Anti-pattern name is Webify Everything, also known as cross-site scripting, cross-site request forgery, US power grid on internet, global financial system on internet. Refactored solution names are physical separation, out-of-band separation, unbalanced primal forces, management of integrity and availability, anecdotal evidence. Why the hell would they put the electrical power grid on internet? Background. In computer technologies, crawl, walk, run evolution, it's become very trendy to eliminate installed applications entirely and rely on web-based interfaces for everything. For the sake of convenience and ease of provisioning, users decreasingly have to install applications anymore. All the headaches of managing applications are conveniently delegated to some remote entity providing the software as a service. In the next field, we have anti-pattern solution. The Webify Everything mindset defies common sense when it is proliferated web interfaces for critical infrastructure. Does it make any sense to proliferate easily maintained and massively replicable remote interfaces to control electric power plants and core network devices? The so-called smart grid. Does Webify its control devices and screens and major providers of network devices Webify their control interfaces? The problem is compounded by common malware technique called as cross-site scripting XSS. What internet browsers do is execute remote code in the form of HTML, JavaScript, and other static and dynamic scripting notations. Hypertext markup language, that is HTML, can no longer be considered a benign static notation. The introduction of HTML 5.0 exacerbates security issues by adding facilities for remote code execution and read-write access to local browser client disks. When remote codes execute in an internet browser, it has complete access all the open browser windows, all their data, and all their implied authorities. XSS attacks combined with webified remote infrastructure control is a recipe for disaster. Whenever remote administrative interfaces are logged in and the user surfs to additional internet sites, there is a distinct possibility that XSS attacks could again control of highly valued infrastructure targets. Supervisory control and data acquisition (SCADA) systems are core control systems of machines, utilities, and manufacturing infrastructure. The Stuxnet worm, which proliferated widely in the Middle East and Asia but only targeted very specific SCADA devices, proved that targeted attacks on SCADA systems are much more than theoretical. In theory, due to the ambitions and capabilities of cyber warriors, in dozens of countries, there are toolkits, backdoors, and logic bombs infecting much of our modern infrastructure power plants, public works, financial systems, defense systems, and possibly air traffic control systems. In the next field, we have causes, symptoms, and consequences. The causes, symptoms, and consequences of this antipattern include web browsers are a user interface platform for applications called thin clients. Thin clients are used ubiquitously and are convenient for system administrators because there is no client software installation or client software updates. Users are in the habit of opening multiple browser tabs and connecting with multiple websites. Websites with malicious content are a significant and prevalent threat. Malicious content, such as malware scripts, can be embedded in the site or served up through advertisements supplied by untrusted third parties. In the next field, we have a refactored solution and examples. Software virtual private networks (VPNs) provide out-of-band separation of communications across public networks. This means that interception of packets using technologies like network sniffers is essentially prevented. VPNs are a widely deployed technology. One wonders why VPNs aren't used universally. For example, providers that send unencrypted emails across the internet are inviting exploitation of the data and possible future attacks. In the next field, we have related solutions. To prevent excesses and other attacks, the American Bankers Association recommends using a dedicated, physically separate computer for all financial transactions. Although this seems to be like an extreme solution, it's a realistic response to the threats. Chances are that a hardened, well-patched computer, which is only used to connect to trusted financial sites, is much likely to be compromised by malware than a computer that is exposed to general internet surfing. Next template is no time for security. Anti-pattern name, no time for security. Also known as add security last. Blame security for schedule slippage. Deliver it now. Refactored solution names. Security requirements are real requirements. Cyber risk management. Unbalanced primal forces. Management of confidentiality, integrity, and availability. Anecdotal evidence. Wait until it's time to test the system and then worry about security. Background. Security is usually the final consideration in the development of a system. Sometimes security is left out altogether in the rush off to get the products out the door. In the next field, we have anti-pattern solution. Developers of software projects and now also the widget developers often wait until the end of the development lifecycle to address security. Near the date that the enterprise release process will test the security vulnerabilities, managers and developers begin a madcap cover-up process to obscure inherently insecure software, user account, and configuration practices. When confronted, developers can claim ignorance. They are not security experts after all. In the next field, we have causes, symptoms, and consequences. The causes, symptoms, and consequences of this anti-pattern include security was never a part of the requirements, saving on development costs and time at the expense of security, project is behind schedule, shared administrator accounts, not training the developers to be security aware. In the next field, we have known exceptions. If the software is out of the box, it is already near the end of development cycle and can be configured for security just prior to development. However, you are taking it on the faith that original software developers accounted for security and built in appropriate configuration settings. In the next field, we have refactored solution and examples. Security risks and requirements should be analyzed early in the development cycle at the same time as functional requirements. This is not as difficult or expensive as it sounds. Business stakeholders should categorize the system such as confidentiality high, integrity medium, and availability medium. You can select the baseline security requirements rather mechanically using these profiles and NIST 853 controls catalog. This delivers a set of security requirements close to the desired set, which you can tailor to specific situation during development. The security requirement should be given first class status in the overall requirement set. In the next field, we have related solutions. You can select security and audit controls using Committee on Sponsoring Organizations and control objectives for information and related technology, frameworks for commercial systems and to satisfy Sarbanes-Oxley requirements. So we are in the last slide for this particular module. In this module, we discussed the following topics, that is, the security architecture, anti-pattern, refactored solution, cyber anti-patterns concept, forces in cyber anti-pattern, cyber anti-pattern templates, cyber security anti-pattern catalog. I can tell in this module, we discussed the new way of thinking about the computer security through a high-level discussion of anti-patterns, which are habitual mistakes made in the IT security industry. A stark assessment of the current state of cyber threats and defenses so that you can have a clear understanding of the growth and significance of cybersecurity threats. The key concepts from the anti-patterns and security architecture are presented, and also some high-profile anti-patterns along with their refactored solutions. A techno-political framework, which is nothing but the anti-patterns catalog, that can foster the organizational change for improved cyber defenses. The core anti-patterns for cybersecurity. And we understood that an anti-pattern is a bad practice that is widely in evidence. Anti-patterns makes you aware of mistakes and give those practices a bad name. An explanation of anti-patterns. A pattern resolves design forces and yields benefits. Anti-patterns resolve design forces and generate mostly consequences which are having negative impact. The primal forces, forces which are almost always present, are functionality, confidentiality, integrity, and availability. Alternative anti-pattern templates are introduced. These structure the anti-patterns with consistent explanations. Thank you.